All right, let's talk about the concept of regulatory cascades specific to the GAP1 checkpoint involving its tumor suppressor genes.
During the first,
I'm going to go ahead and mute this guy. First of all, if you remember, during that during that GAP1 checkpoint, the cell has to be checked for cell size, but more importantly, or just as important, is to make sure the DNA doesn't have any errors or mutations that could potentially be passed on to the next generation of cells. So there's several different events that are going to occur here, involving cascades and chain reactions to help keep this thing tightly regulated. First thing we need to understand is that there's a protein called retinoblastoma, RB, and another protein called E2F. E2F comes from a family of transcription factors that basically their job is to go and they attach to DNA sections of DNA and increase or amplify the amount of proteins made from that section. And those proteins will have, of course, downhill effects on other things and other processes. This transcription factor happens to influence the production of proteins that will cause this cell cycle to move on into the next stage. So yeah, it flips a switch to start a signal transduction pathway necessary for making it move on into the S phase. So that's what E2F is. Again, and RB and E2F, because of their molecular shape, they bind together, and as long as E2F is locked up, that checkpoint stays halted, because if E2F happens to be free, then E2F can go and flip the switch, so to speak, or cause transcription to occur that's going to set in motion a series of events that's going to cause that cell to progress on into the cell cycle. And again, if it's running amok, then it's going to go ahead and move on to that next stage before the cell is actually ready, or should. So it's important. RB has to make sure it fits in there, because that's going to freeze up E2F and prevent them from moving on before we need to. Now, other molecules involved are CDK and cyclin. All right, CDK and cyclin are necessary because when they combine, all right, we're assuming everything's okay. There's no errors, cell's big enough, all that stuff's okay. When it's okay, CDK and cyclin combine with one another, then and I understand this animation doesn't show everything, but in a simplified manner, they will go and they will interact with that RB-E2F complex, that combination of those two proteins, and cause E2F to separate from RB. And like I said, when E2F is separated, it will go and signal another pathway to start, which is necessary to make that cell progress into the next stage of the cell cycle. Now, backing up here, there's some other things that occur though when this thing gets frozen. When RB attaches to E2F, it blocks growth. It stops it so that, I'm going to skip ahead here, so that P53, another molecule, has a chance to basically attach the DNA and then roll over it to make sure there are no errors. If there's no errors, then this event right here happens, all right? CDK and cyclin connect, and then they free E2F, and then it moves on like normal. But if there is an error, as it shows here in the diagram, P53 will activate a repair system, a completely separate regulatory cascade or transduction pathway involving a whole separate host of proteins that come in and repair this thing. All right, but in order to provide enough time for that to occur, P53 has to also simultaneously activate another protein called P21, and it's just an interferon. It's going to interfere with CDK and cyclin and prevent them from combining. All right, and that's important because remember, when they combine, let's look at it again. When they combine, they go and they release E2F. So in order to keep them from combining, and in turn keeping E2F locked up and preventing it from flipping the switch to make this thing move on before it's ready, P21 is created, gets in the way, prevents them from binding, and as long as they can't bind together, E2F stays locked up, and then the cycle stays halted. Once the repairs are made up here, P21 will fall off, allowing CDK and cyclin to combine, allowing them to combine, and then in turn releasing E2F. and causing the cell cycle to progress on into the next stage. Again, that's kind of the rundown explanation of that checkpoint. And again, we focused on that to give us kind of a general conceptual understanding of how these cascades work to ensure cell quality and prevent dysplasia and eventually possibly cancer. Because again, if this one messes up, then everything else downhill in the cycle is going to be messed up as well. So again, hope that helps. Good luck. Have a great day.